Hello dear students, I Professor Saurabh Deshpande welcome you all to our YouTube channel Tulips Academy. Today we are going to see third numerical on analysis of truss by using method of joints. Let me read the problem statement first. The truss supports vertical loads as shown in figure. As you can see in the figure, the truss is subjected to two vertically downward loads. No horizontal load is present on the truss. Determine the forces in all the members of truss and state the nature of forces in tabular form. See, there are two methods of analysis of truss, method of joints and method of sections. Sometimes it is mentioned in the problem statement which method is to be preferred. Sometimes it is not mentioned in the problem statement. So here the method which you have to use for the analysis of the truss is not mentioned. So how to determine whether we have to go with the method of joints or method of sections? So it is very easy. If you have to find forces in all the members of truss, then you must go with the method of joints. And if the members are specifically given in the problem statement, then you have to go with the method of sections. The method of sections we will see in the next video. But here we have to determine forces in all the members of truss, so you must go with the method of joints only. So let us follow our steps. So step number one, step number one is stability check of the truss. So first of all, let us measure the number of members of the truss. How many members are present for the truss? First of all, measure the peripheral members and then measure the internal members. So 1, 2, 3, 4, 5. 5 peripheral members and 2 internal members. Total number of members are 7. So M is equal to 7. Then J stands for number of joints. Measure number of joints A, B, C, D, E. There are total 5 joints. So J equal to 5. And probable number of reactions are, let me calculate probable number of reactions by using properties of supports. If you look at the supports, at point D, a hinge support is provided, and we know the property of hinge. At hinge, two reactions are possible, one horizontal reaction and one vertical reaction. So I will draw two reactions. A horizontal reaction is drawn towards right. This is assumption. After calculation, we will get to know whether our assumption is correct or wrong by looking at the sign of this reaction. If the sign of reaction is positive, then our assumption is correct, otherwise it is wrong. And vertical reaction, I will assume it in the vertically upward direction. Let me call horizontal reaction as HD and vertical reaction as VD. And if you look at point E, roller support is provided, and we know that property of roller is roller support offers only one reaction perpendicular to the plane of the roller, and here plane of the roller is vertical, and therefore reaction which is perpendicular to the plane of the roller must be horizontal. So I will draw the horizontal reaction, and this reaction is also assumed towards the right, that is towards positive x direction. All the reactions are initially assumed in their respective positive directions, and after the calculation the true directions of the reactions are calculated. So let me call this reaction as HE, horizontal reaction at point E. So total number of reactions, probable reactions are 3. So value of R comes to be 3. Okay. Now I will calculate 2J minus R. What is 2J minus R? 2 into J is 5 minus R is 3. That is 10 minus 3 is equal to 7. And if you look at number of members, they are also 7. So I can write M equal to 2J minus R, and therefore my truss is determinate truss. Determinate or perfectly stable truss. So first step is completed. Now second step, step number 2, that is calculation of reactions. Calculation of reactions. Okay. Now consider free body diagram of the entire truss. Here you have 3 equations available with you and 3 unknowns available with you. So let us go one by one. First of all, let us use summation fx equal to 0. So first equation, summation fx equal to 0. Sign conventions are the forces which are acting towards positive x are positive, forces which are acting towards negative x are negative. Okay. Now if you look here, along x direction there is only one force, there are two forces, HD and HE. and both are assumed towards their respective positive directions. So therefore our equation comes to be plus hd plus he is equal to 0. So let me write first equation, hd plus he is equal to 0. Let me call this as equation number 1. Now second equation, summation fy equal to 0. Vertically upward forces are considered as positive, vertically downward forces as considered as negative. You must write the sign conventions. Here there are 3 forces acting in the y direction, Vd assumed in the vertically upward direction, and 6 kN and 3 kN external forces acting in the vertically downward direction. So there are 3 forces. So I can write the equation like plus Vd, because it is acting in the vertically upward direction, minus 6 minus 3. These 2 external forces are acting in vertically downward direction, so they are negative, is equal to 0. So Vd equal to 9 kN. As Vd comes to be positive, our assumed direction is correct and Vd is acting in the vertically upward direction. That's it. Our first unknown is calculated. Now let me take the moment of all the forces about point E or point D, either E or D. So let me take moment about point D. The benefit behind taking the moment about point D is there are 2 unknowns acting at point D, and when I will take the moment about point D, moment of both the unknowns about point D will become 0 and I will directly get value of HE. So that is the biggest advantage of taking moment about point D. In general also, you must take the moment about that point where maximum number of unknowns are present, so that your calculation will get easier, calculation will get simpler. Okay, so take moment about point D. So sum of moment, summation of moment of all the forces about D equal to 0. Here clockwise moments are positive, anti-clockwise moments are negative. This is our sign convention. You can choose your sign convention. Somebody may take anti-clockwise moments are positive and clockwise moments as negative. It is also correct. Okay. So here we are taking moment about D. So moment of HD about D will be 0 because line of action is passing through point D. Moment of VD about point D will be 0. Moment of HE about D will be anti-clockwise. I have already told you how to determine nature of the moment, sense of the moment. Put your thumb over point D and rotate your index finger in the direction of HE. So that will come to be anti-clockwise. This will be anti-clockwise moment and therefore it is minus. So minus HE into perpendicular distance. Line of action of HE is horizontal, so perpendicular distance must be vertical and it is given as 1.2. So minus HE into 1.2 will be the moment. Minus HE into 1.2. Moment of 6 kN is and clockwise, so it is positive. So plus 6 multiplied by perpendicular distance is 1.2. So plus 6 into 1.2. And last moment of this 3 kN force, it is also positive, clockwise, so it is positive. So plus 3 multiplied by line of action is vertical, so distance must be horizontal. So horizontal distance between 3 kN force and point D is 1.2 plus 1.2, that is 2.4. So plus 3 into 2.4. Plus 3 into 2.4 is equal to 0. And therefore solve this equation, this minus term it become plus when it will go to the right hand side, so it will become plus 1.2 HE is equal to, calculate these 2 terms on the left hand side. So they will come to be 6 into 1.2 plus 3 into 2.4. So it is 14.4 and therefore HE comes to be 14.4 divided by 1.2. 14.4 divided by 1.2. So it is 12 kN. Exactly 12 kN. Positive, it means that our assumed direction is correct and it is acting towards right. And now put this value in equation number 1. So from equation 1, HD plus HE is equal to 0. So here HD plus HE, so plus 12 is equal to 0. So HD comes to be minus 12 kN. A minus sign indicates that our assumption is wrong and HE is acting towards left. That's it. So second step is also completed. Now third step. Step number 3, calculation of member forces. So you should start with the joint where minimum number of unknowns are present. If you look at point E, at point E, there are four forces, 3 member forces and 1 reaction. 3 member forces cannot be calculated by using 2 equations because at every joint 2 equations are available. So you can't start with point E. You can start with point D because at point D, total 4 forces are present. Out of 4 forces, 2 reactions are known to you and 2 member forces are unknown. And here, what is the benefit of starting your analysis from point D is 2 forces are horizontal and 2 forces are vertical, so it is not necessary to resolve the forces. Resolution is eliminated and therefore your problem will get easier and you can solve the entire problem within a very short duration of time. So you should always search for that joint where resolution process is minimum or it is eliminated. At point D it is eliminated, so let us start from point D. So FBD of joint D. FBD of joint D. So at joint D, if you see, this is joint D. At joint D, HD is present, but direction of HD is towards left, which I have already calculated. So let me draw HD towards left. This is HD, value is 12 kilonewton. Here while writing, do not write negative sign, write only magnitude. Then VD, one vertically upward reaction which is positive, and value of VD is already calculated. VD is 9 kilonewton vertically upward, so show it. And then member forces. Member force in DC and DE. Assume both the member forces are tensile as initial assumption. So this is FDC towards its positive direction and this is FDE towards its positive direction. Assumption may be right or wrong. Now we have to decide whether the assumption is correct or wrong. So first of all, use summation fx equal to 0 as per your usual sign conventions. So along its direction 2 forces are acting. FDC along its positive direction, so plus FDC minus 12 is equal to 0. So FDC is plus 12 kilonewton. Plus sign indicates that our assumption is correct and FDC is tensile acting away from the joint. Then summation Fy is 0. So along y direction 2 forces are present. You look at the free body diagram and both the forces are in the vertically upward direction. So plus 9 plus FDE is equal to 0. 9 plus FDE is equal to 0. Oh, sorry, I'm extremely sorry. FDE is assumed as compressive here. So we have to assume it as a tensile. I'm extremely sorry here. Assume FDE as tensile, not in vertically upward direction. Okay. So FDE is also tensile and it is vertically downward, so it is negative. It is negative. And therefore, negative on the right hand side it will become positive. So FDE will be 9 kilonewton. As FDE also comes to be positive, our assumption is correct and FDE is tensile. So both FDC and FDE are tensile. So let me show them on the figure. So FDC is also tensile, so forces will be away from their respective joints. Similarly, FDE is also tensile, so forces are away from their respective joints. That's it. Now next, let us come to the point B. Now if you look at joint B, T is formed. And 2 forces are linear, collinear, acting along the same line of action, and 1 force is in the vertically one force is acting along y direction. And along y direction, if you go with equation summation Fy equal to 0, then only 1 force is present, that is FBC, member force in member BC, and no any other force, no any external force is present which can balance this member force, and therefore member BC is 0 force member. Member BC must be a 0 force member. If I will apply external force at joint B, then member BC will not be a zero force member, it will contain the force. But right now, no any external force is present along y direction which can balance the force in member BC, and therefore member BC must be a zero force member. You can draw free body diagram of joint B, and from that you can prove that no force is present in member BC. Now, if you go with joint B, you cannot analyze joint B right now because you neither know force in member BE nor you can know the force in member BA. So you cannot start with joint B now. So let us go with joint A, because at joint A two member forces are present, that is two unknowns are there and two equations are there. Only difference is that we have to find this theta. Now if you look at this is also theta, this is also theta. This is isosceles triangle. This angle, opposite side of the angle is 1.2 meter, adjacent side of the angle is also 1.2 meter, and in this triangle also, in this right angle triangle also, this is angle theta, opposite side is 1.2, adjacent side is 1.2. It means that both the angles are same, and as opposite side and adjacent side both are same, therefore your theta must be 45 degree, and you can prove it by using tan theta relation. Tan theta equal to opposite upon adjacent. Opposite is 1.2, adjacent side is 1.2, 1.2 upon 1.2 will be 1, tan theta is 1, so theta will be tan inverse of 1, that is 45 degree. So here theta will become 45 degree. So now I will go with free body diagram of joint A. Let us draw free body diagram of joint A. Now at A, one vertically downward force is present, whose magnitude is 3 kN, and two member forces are present, member force in member AC and AB. Assume both has tensile. Initially assume both the forces as tensile forces. So this is FBC, I think, yes, and horizontal force is FAB, sorry, FAB and AC, sorry, FAC. Okay, and angle we have already calculated, it is 45 degree. Okay, now you have to resolve the force. Two forces are already acting along their axis, 3 kN along negative y axis and FAB along negative x axis. But FAC, according to our quadrant system, according to our Cartesian coordinate system, FAC is along in the second quadrant, acting in the second quadrant, because this is my positive x direction, this is my positive y direction, this is my negative x direction, and this is my negative y direction. So according to quadrant system, it is in second quadrant. As per property of second quadrant, x must be negative, y must be negative. So I will resolve it here so that confusion will be avoided. So this will be negative x component, this will be negative x and positive y. X component will be negative, y component will be positive as per sign conventions of second quadrant. This angle is 45 degree. Angle is adjacent to the x component, so x component will be cos. So this will be FAC cos of 45, and this will be FAC sin of 45. Now use equations as usual. Summation fx equal to 0. In x direction, how many forces are acting? Two forces are acting, FAB and FAC cos 45, both along negative x direction, so both are negative. So minus FAB minus FAC cos 45 is equal to 0, and therefore take negative sign as common, and when it will go to the right hand side, it will become 0. So equation turns to be FAB plus FAC cos 45 is equal to 0. Let me call this as equation A. Now summation Fy equal to 0. So in y direction, two forces are acting, FAC sin 45 and 3 kN. So FAC sin 45 along positive y direction, so it is positive, 3 kN along negative y, so it is negative. So FAC sin 45 minus 3 equal to 0. So FAC is equal to 3 divided by sin 45. So FAC turns to be 3 divided by sin of 45. So it is 4.243. 4.243 kilonewton. As it is positive, our assumption is correct and it is tensile. Now put this value in equation number A. So from equation A, FAB plus FAC is 4.243 into cos of 45 is equal to 0, and FAB will become, this is a positive on the left hand side, it will become negative on the right hand side. Let me calculate the value. 4.243 cos 45, 4.243 into cos 45, it comes to be 3 kilonewton. So FAB is minus 3 kilonewton. Minus sign indicates that it is compressive. Our assumption is wrong. So FAB is compressive and AC is tensile. FAB is compressive, that is towards the joint, and AC is tensile, that is away from the joint. Now, without taking free body diagram of joint B, I can easily observe, by only observation, I can easily say that force in member BA must be equal to force in member B, as at point B only two forces are present along x direction and both must balance each other. So force in member BE is same as force in member BA, and nature is also same. So this is also compressive, so that at joint B both the forces will balance each other and the joint will be in equilibrium. That's it. Now only one force is remaining, only one member force is remaining, that is force in member EC. So you can take a free body diagram of any joint. Let me take free body diagram of joint E. So at joint E, one reaction is present, HE. Three member forces are present, out of which two member forces are already calculated. So I can calculate third member force very easily. So free body diagram of joint E. Next step, last step actually, FBD of joint E. So at joint E, this is my joint E. This is, I think, E. So at E, HE horizontal reaction is present, where the direction of HE is towards right, which I already calculated, 12 kilonewton towards right. So let me show it. Towards right. Okay. Then two member forces, actually three member forces. This member force in member BE is compressive in nature, that is acting towards the joint. So I will show it, compressive, acting towards the joint. And its value will be same as member AB, that is 3 kilonewton. So this is also 3 kilonewton. That's it. Then member DE, force in member DE or ED, which is tensile. I will show it, tensile, and value is 9 kilonewton, tensile. So this will be 9 kilonewton. And third force remaining is EC or CE. I don't know the nature of the force, so I will assume it as a tensile acting away from the joint. So this is F, CE or EC. This is 45 degree again. Now resolve the forces. Use any one equation. Resolve FCE. So its x component will be along positive x, y component will be along positive y, because it is in the first quadrant. So resolve it and use summation Fy equal to 0, because it is easier. So 9 kilonewton is acting along positive y, so plus 9. And here y component of FCE will be sine component, because 45 degrees with respect to x axis, adjacent to x axis. So x component will be cos, y component will be sine, and it is acting along positive y, so plus FCE sine 45 is equal to 0, and therefore FCE sine 45 is equal to minus 9, and FCE will be 9 upon sine 45, minus 9 divided by sine 45. So it is minus 12.728, minus 12.728 kilonewton. Minus and indicate that it is compressive in nature. So FCE is compressive. Show the nature in figure. FCE is compressive, that is acting towards the joint. That's it. So here truss is analyzed. Now you have to only tabulate the values. How to tabulate the values you have already known. So the problem is for 6 marks, and these are the steps to follow the problem and to approach the solution. If you like this video, please subscribe to our channel. The name of the channel is given here, and this is my mobile number. And if you want updates of the videos, then press the bell icon. You will get the regular updates of the videos. Thank you very much.